Hello everybody. In this video we are going to see how to use OpenGL in Flutter on Android. This is going to be our test application. It's a very simple application. We load an image and we apply a blur filter to the image. We can change the blur radius using this slider here, and whenever we change the slider we rerun our OpenGL filter and blur the image. And now instead of doing a code along type of tutorial, this is going to be like more of a code review or code walkthrough, because doing a code along will make a very long video. So with that, let's get started and take a look on our solution architecture. So our project is going to have like two components. The first one is going to be our filter application, and the second one is going to be the filter plugin. And now we develop the filter as a plugin, so we can reuse this plugin in various applications. So we separate these two components. The application is just a very simple application, as you saw. We have this filter preview widget. This is a widget that is provided by the filter plugin. So we just render this widget, and the filter plugin also provides us with a filter controller. This is a class that let us control the filter, and whenever the slider is moving, we are calling to the draw method on the filter controller. We provided the new blur radius. Our OpenGL program is running and is rendering a new image, where we see the new image in our filter preview widget. As for our filter plugin, it's a little bit more complex. So the plugin is divided into two. We have the Flutter side and we have the Android side. In the Flutter side, we developed the filter preview widget, and this is a simple widget. All it does basically is just render a texture widget. Texture widget is a widget that we get from Flutter, and it knows to render an OpenGL texture or any surface texture. And then we have our Android side of the plugin. This is where we are going to develop the OpenGL filter, and where we are going to create this surface texture where we are going to render the OpenGL output into. And then this surface texture is going to get displayed inside this texture widget. Now, in order to communicate between the Flutter side of the application and the Android side of the filter, so we have the Flutter side of the filter, the Android side of the filter. They need to communicate with each other. So we have this method channel where we can pass messages back and forth between the two sides. This is a standard Flutter plugin. So if you developed a plugin in the past, you are very familiar with this method channel and how it works. So let's take a look on the code. Now I'm going to leave this diagram here during the entire video, so because we're going to refer to it quite a lot. So this is our filter app. This is the application, and we have this the filter page. This is the page that we saw with the image, and in our build method we are just going to render the filter preview as we see here in the diagram, and we are going to render this this slider. Whenever the slider changes, we are going to call to the controller and ask the filter to draw a new image or run the filter using the new radius. Now let's see, when our page or our widget is getting initialized, so here in the init state we are calling to the init method. Here we are loading the image. Now the image is embedded in the application. Here under asset drawable we have the Matterhorn image. So we are loading the image, Now we need to get the actual bytes. We need to get the RGBA bytes of the image. So basically, this is what we are doing. This is what we are doing here. We are getting the image from the asset. We are resolving the image, and then we are creating a listener that we want to wait until the image is loaded. So we create a listener, here. We add this listener to the image resolver, and we wait. Once the image is loaded, we are getting the image info. This is an image info class, and then we can call to our init filter controller. In the init filter controller, we take the image info and we get the bytes of the image. So we get the raw RGBA. Then having the image bytes, we can we create an instance of filter controller, and we call to the initialize method of the filter controller, and we provide it with the image bytes, the width and the height of the image. And then we do the initial drawing after we initialize the filter. So that's it for the application. Very simple application. And now let's go and take a look on the filter plugin. So first, let's take a look on the filter preview widget. Very simple widget. Important, we get the filter controller on the constructor, so we can see in the filter app here, when we render the filter preview, we provide it with the controller. So we get the controller, and then in the build method, we just render an aspect ratio widget using the image width and height, and then we render this texture widget from Flutter, and we need to provide it with texture ID. So this is the underlying surface texture that the OpenGL is going to render onto, and we will get this texture ID again from the controller. It will hold the texture ID. If we take a look at the controller, so first we create our method channel. So this is this channel where we are going to communicate from this Flutter side of the filter to the Android side. And we use this name. You will see that we are going to use this very same name on the Android side of the plugin. And then we create the controller. We just hold some local member, whether we are initialized or not, the texture ID. So this is going to be the surface texture that the OpenGL is rendering into, and the width and the height of the image. We have the initialize method. So this is this initialize method from our filter app. After we loaded the image, we call the initialize method. So this is the method. We get the image bytes, the RGBA bytes, the width and the height. And here we are going to make the first method call to the Android side. So we are creating the parameter of the call. We are going to send the image, the width and the height, and then we are going to the channel, invoke mapped method, and we are invoking the create method on the channel. This create method on the Android side, this is going to create it's going to create an instance of the blur filter, and the response of this create method is going to be the texture ID. So the create method, part of creating the blur filter, it is also going to create the output texture, and it's going to return the texture ID. And in the dispose, we are just calling to the Android side to the dispose method. This is going to clean up any resources of the filter, the texture, etc. And our draw method. So whenever the user is moving the slider, this method is going to get called with a new blur radius. And again, here we're going to invoke a method on the Android side of our plugin. We are going to call the draw method, and we will provide the new radius. And then in the Android side, when this method is getting called, we are actually going to called we are going to rerun our OpenGL program with the new radius, which is going to render the image with the new blurred image using the new radius. So that's it for our Flutter side of the plugin. The key takeaways is that we have our filter controller. We are going to create an instance of the OpenGL filter. We are going to store the texture ID. This is the texture that the OpenGL will render the blurred image into, and in our in our filter preview widget, we are just going to display this texture. So that's it for the Flutter side. Now let's move to the Android side of the plugin. So this is the Android side. We are inside Android Studio. Now in our Android Studio, we have the filter plugin, and the filter plugin. This is our class. It inherits from a Flutter plugin, and it implements the method called handler interface. This is like any other plugin. So what we have here, we have this on attached to engine. This method is going to get called when our plugin is created, and here we are going to create the channel, this channel which we're going to communicate with the Flutter side of our plugin, and you see that we are using the very name channel ID, and then we are setting our plugin class to be the method called handler. This is why we are implementing this interface. And whenever the Flutter side is going to call a method, like we saw the draw method, for example, this method on method call is going to get called. And here we are doing a switch case on what method was called, and we are handling it. We are handling each method. So the first method, when we are creating the Flutter preview, we saw that we are calling to the create method. So in the create method, we are going to create an instance of our blur filter. So let's take a look and create filter. So this is the create filter. If you remember, the parameters that we get are the width, height, and image. So here, this is our Flutter side of the plugin. We are in the controller, and we are calling the create method, and we are passing the image, the width, and the height. So we get these three parameters. We prepare our response, our reply object. Now, if we get an image, maybe if we don't get an image here, this is not okay. So maybe we want to return an error or something. So what we do with the image, we are converting the image to bitmap, and here we are creating the texture that the OpenGL is going to render onto. So this is important. What we do, so on this method, on attached to engine, the Flutter engine is going to call this method when our plugin is created, and it is going to provide us with this Flutter plugin binding. We save this Flutter binding to our plugin binding member here, and then when it's time to create a texture, so we are using the plugin binding texture registry create surface texture. Okay, and this return here surface texture entry. Using this entry, we can actually get a surface texture, and so this one, surface texture. This is the result. And having this surface texture, we are creating a surface. So eventually our OpenGL will need a surface. So we are creating here a surface object using the surface texture that we got from Flutter. And now when we have the image, and we have the texture. We can create the instance, create an instance of our filter. So this is our Gaussian blur filter, and the response of our create method is the texture ID. So we just return the texture ID here, and in the Flutter side of our plugin, we invoked the create method, and in the response we take the texture ID, and this is the texture ID that we are rendering to the output using the texture widget. So this is how we initialize the filter. Now, whenever the user move the slider, as you saw, we are calling to the draw method. So again, in the filter controller, we have a draw method that is getting called, and this is invoking the draw method on the channel. This invoke method is getting to the Android side of our plugin to here to this draw method. We make sure that we are initialized and we have an instance of our filter. If not, we just result an error. Otherwise, we just call to the draw method on our Gaussian filter, and we return an empty response. We don't need to return any response because this draw method is just going to draw onto the surface that we already displaying in the application. So this is the draw method, and that's it for our filter plugin class. Now let's go to our Gaussian blur filter, and this is where we are going to have the OpenGL rendering. Now, this tutorial is not about OpenGL and how to write OpenGL. It's just how it's about how to use OpenGL in Flutter. If you want an intro to OpenGL, I have this blog post about understanding the OpenGL triangle. There is also a video. This is with WebGL, but the concepts are really the same, like on OpenGL on Android. So this is our filter class, and as you remember, on the constructor we get the output surface. So this is the surface that we got from Flutter, and we got the source image. Credit for where it's due. So the Gaussian blur fragment shader I took from this website. Now we are not going to go over all the code of how we initialize OpenGL and that stuff. We will just I just want to emphasize how we are using the output surface in order to render on the Flutter on the surface that we got from Flutter. So where we initialize our OpenGL context, we are using the default display, and blah blah blah, and here we are creating our OpenGL context using this display, and then here at the very last line we are creating a Windows surface, and this Windows surface we are going to use the output surface that we got from Flutter as the underlying window. If we take a look on the documentation of EGL create Windows surface, so we have the display and the third parameter. This is the native window. Specify the native window. So basically our native window is the surface that we got from Flutter. So this is how we create the EGL surface. And then we have here the program setup, the texture code, all the parameters from the for the fragment shader. So we just set up the program, and then we have the draw method. So every time the user is moving the slider, we are going to call to the draw method on our filter controller, which is going to call to the draw method on our plugin, and here we are going to call to the draw method on our filter. So essentially this is this method. What we do here, we make our context, our OpenGL context as the current context. We use our program. We set the new radius, as the parameter. We update fragment shader radius parameter with the new radius. Flip y. This is not really relevant. We bind our input image. We make sure that there is no frame buffer that is currently bounded. Remember, we are not the only OpenGL program that is running in the application. So before we render using our program, we want to make sure that we are not rendering to some other output buffer. So this is what we do here. And essentially, we are calling to the draw array method of OpenGL. And the most important thing is calling EGL swap buffer, which basically take the output of our draw method and renders it to the EGL surface. If we look at the documentation of the EGL swap buffer, so it posts EGL surface color buffer to a native window. Remember that this surface that we provide here is essentially the textured surface that we got from Flutter. So if surface is a backed buffered window surface, then the color buffer is copied to the native window associated with this surface. Essentially, this what renders the image to the texture surface that we got from Flutter. And we have the destroy method where we just we recycle, we free the input BMP, or the texture, and the display. Basically, we just free everything, I hope. Okay, so the key takeaway from here, on our filter, we get this surface to be the output surface, and we get this surface from Flutter. So Flutters know how to display this surface in the application, and using this surface, we are creating an EGL surface backed by this texture that we got from Flutter. And after we are running our program, after calling to draw, we are calling to swap buffers, and we are taking the output from our OpenGL and render it into the surface that we got from Flutter. And that's pretty much it. So if we look again on our application, we have this image, which is essentially this Flutter preview widget, and inside this filter preview widget, we are just rendering the texture widget, and this texture widget knows to render and output surface textures that we get from Flutter. So the image that we see here is essentially the surface texture that we get from Flutter, and every time that we are moving the slider, we are calling to the draw method on OpenGL, which renders a new image on this surface texture, and this is what we see here. I hope you will find this tutorial useful, and happy coding.